Hello everyone, welcome to my show Rocket Monday, episode number 4, where we're gonna take a look into rocket propellants. So let's get started. So question comes to mind, what is it? In simplest term, it's basically the 90% of rocket. When you see a rocket like this, you have only that part, the H part is the actual payload, everything else is just fuel basically. And it is what's a reactionary mass. Basically, this is what rocket engines throws at the back and get pushed up. So this is what also called as a propulsive mass. Now you have to understand this. If you throw solid or liquid directly like that, it's not going to give you much thrust. For getting thrust, we use what's called exothermic chemical reaction. What does that mean? Simplest sense, you burn the fuel. Like either we can have hydrogen, oxygen, nitrous oxide, uh, other fuels also, and that's how we get the actual rocket to go up. So let's look into it more. Now, what types of fuels are used? Now, we have solid, obviously, we have liquid, and then there is a hybrid which allows you to mix both of them. Now, each of them has its unique ability, so let's look into them. So we come to solid propellant. So it has the first biggest advantage is cheap. Your firecracker is made out of that because it's cheap. Then it is very easy to store. Now what does that mean? That simply means you can have a rocket that's ready to go on moment's notice or instantaneously without needing any refueling or fuel prepping, fuel topping procedures that are generally associated with liquid fueled rocket, which makes it ludicrously attractive for military application. Earlier ICBMs used to have liquid fuel, but then they were phased out because of advancement in solid rocket boosters, and you really want to make sure your ICBM is ready on a moment's notice, not like, okay, we're gonna fuel it up for half an hour and then we're gonna launch it. You might not have land left after that. So uh, ICBM needs instant response time. For that reason, solid boosters satisfies it very well. Now, if it's cheap, it's easy to work with, it has enough power, then why don't we use it all the time? It does have some side effects. First is, it is very low efficiency. What does that mean? In simplest term, the mileage is very low. It's like a truck with very shitty mileage. Second, now that you might be able to contract, but what you can't contract is that it has no control. What does that mean? Simply, let's say you're firing a rocket and it goes up to a point where in atmosphere it starts to create drag on it. Generally at that time rockets throttle down a bit so they don't create a dangerous vibration. You can't do that on solid boosters. It will create a maximum thrust or whatever it's designed to do, and you can't throttle it. Or let's say atmospheric pressure changed and you're like, okay, we really need to increase the boost to compensate. You can't. So there is no control into it. So for military it's okay, for cheap and easy use it's quite good, but it does have some side effects. So let's look at its counterpart. So we come to its counterpart, which is liquid propellant. So we have to understand this. The sole reason we even bothered with liquid propellant is it's a very high efficiency, specifically in vacuum, and it's capable of restart. So what does that mean? Let's say you put something in orbit, let's say a spaceship, but you also have to deorbit it, so you can bring the humans back. Now for deorbiting burn, you need to reignite the engine. This is where the capability of restarting the engine comes in handy. Without it, you kind of stuck. So that's why military uses it, because they really don't want to slow down or things like that. So but for human application, you really want to make sure your engine is capable of restarting. Then it comes down to very fine point control. It means a lot. Basically, without this control, rocket will keep getting lighter and lighter, and the engine will keep producing more and more thrust. Now it's good and all that, but problem is you might end up crushing the satellite that you are sending into orbit. So many times you heard in SpaceX launches, in live telecast, they will say they are throttling back the engine, like specifically around max Q, where atmosphere is fighting the most. So they're like, chill the engine. They're still going at very fast speed. They are just chilling down the acceleration. So they are like, let's say is generally accelerating on 3 Gs, they are like toning it down to 2 Gs, so rocket can handle the vibration that is induced by atmosphere. Or let's say they are going in space and rocket is 80% empty. Now engines are getting like really excited, and it's getting a lot of thrust. Here's the problem: the satellites are barely rated to 5G, and you really don't want to push it, because if that shatters inside the payload, it's dead basically. So they're gonna be like, okay, chill. So control really matters, specifically for human application and where you don't actually want to blow things up. The side effect of this part is this puppy engines. They are expensive, very, very, very expensive. I mean, like, they can cost upwards of 50 to 80% of the rocket itself, and they are very sensitive. What does that mean? Basically, when you see a rocket like this, Falcon 9, this is only fueled up when it's at the launch pad. It's not like your car where you keep it fueled up. No, this is fueled up at the launch pad. And here's the deal: it's fueled up at the last minute. It's not like, okay, today we're gonna have a launch. No, it's like, oh, we're gonna launch in next 30 seconds. They're gonna top up the fuel. So you before the launch of any rocket, you would see there is a long procedure of fueling up. That's because of these things. And many liquid propellants are cryogenic. Basically, they can't be kept in a tank for a long time. You fill it up, you fire it. You don't have the time, because it will start to evaporate. So those are the few pros and cons of the liquid propellant. So now we have the solid propellant. Now we have liquid propellant. Now there is another third kid in town: hybrid propellants. Now you must have heard this term, hybrid rockets. So what does that mean? Well, it has best of both worlds. It's cheap, it's controllable. Now, however, because it's the best of both worlds, it's actually not great at either. It's just okay. It's a spaceship 1 and a spaceship 2 both use them. And aside from them, there is not much application of this sort of thing, because while they use a solid fuel, they generally have a liquid auxiliary. It could be nitrous oxide, it could be hydrogen peroxide, sometimes it could be liquid oxygen. Now you are controlling that, the valve, you are controlling the oxygen fluid, so you are controlling how fast your solid booster is burning. However, you don't get benefit of mileage benefit of fully liquid system, or you don't get the, like, always on ability of a solid booster. So it's kind of meh, and that's why you don't see them used in very large system. They are generally limited to small applications like this. So that was my presentation for rocket propellants, and I hope you like the presentation. If you liked it, please like. If you didn't like it, dislike and leave a comment. If you enjoyed it, please subscribe and press the bell icon if you're free. Thanks for watching.